position of two lines relative to each other. Okay, so we have two lines, let's say this one and this one, two lines. Because these lines we have, let's say this L1, this L2. So we have direction vector D1, and this one also we have D2. Also we have 2 points. One, let's say the P1, and the other one is P2. Now we have three vectors here, D1, D2, and P1, P2, line segment as a vector. So if these three vectors are linearly dependent, then they will be on the same plane. So it is not on the three-dimensional object, it will be on the same plane. So otherwise, so if this one, let's say mixed product D1, D2, and P1, P2. If this is not 0, then these two lines are skew. So it means if you have this one, let's say the D, so let's say this would, case 1. So if D1 is this, P1, Q1, R1, and D2 is P2, Q2, R2, and let's say P1 is X1, Y1, Z1, and P2 is X2, Y2, and Z2, then L1 and L2 are skew if and only if these determinant, let's say this one, so P1, P1, PQ1, R1, P2, Q2, R2, and X2 minus X1, Y2 minus Y1, and Z2 minus Z1 will not be 0. So this is the case 1. So case 2, if this is the 0, so let's say 2, if D1, D2, and P1, P2 is 0, but D1 and D2 are parallel. Then L1 and L2, these two lines are parallel. Because in this case, these three vectors will be on the same plane, so it means the two lines are on the same plane. So either they will be parallel or they will intersect each other. If the direction vectors are parallel, it means the lines are parallel. So case 3, if D1, D2, and P1, P2 is 0, and D1 and D2 are not parallel, then two lines, L1 and L2, intersect each other. So how to find this intersection point? Same. When you try to find something common, you need to solve the two equations together. Okay, how to find the intersection point? To find the intersection point, now L1 is this because we have the point x minus x1 over p1, x minus x2 y1 over q1, right? So this will be y minus y1, and z minus z1 over r1. This is the 1. So let's say t. L2, we have this one in this case, y minus y2 q2, and z minus z2 r2. So let's say t again. So from these lines we have these equations. The first one, so x equals okay, let me put this one lambda and mu. Okay, lambda and mu. So first one is lambda p1 times lambda plus x1. Second, q1 times lambda plus y1, and z r1 times lambda plus z1. This is line L1, the first line. Second line will be parametric equations, p2 times mu plus x2, this is the x, y becomes q2 times mu plus y2, and z will be r2 times mu plus z2. Okay. So because we will solve these two equations together, then we have this one from these equations. So P1 times lambda minus P2 times mu equals x2 minus x1. The second one, okay, let me okay, this is the one. The second one, q1 times lambda minus q2 times mu equals y2 minus y1. And the last one, r1 times lambda r2 times mu equals z2 minus z1. Find the common solution. So we have a linear equations here, the system. So we need to solve this equation. If you look at this equation, there are three equations, two unknowns. So you need to solve the two equations together and then find the result. But you need to check this result in the other equation. Again, you don't need to memorize these three cases. So you just find the solution, okay? You find. So let's say this is A. Okay, let me put A. So this one, if when you solve these equations, if you find the solution, it means there is only one solution. So your two lines are intersect each other if there is a solution. If there is no solution, it means either they are parallel or they are skew. They are in different planes. Okay? Okay, let me note this one. So if the system A has a unique solution, then L1 and L2 intersect each other, and the solution gives the intersection point. Okay, if the system A has no solution, then either L1 and L2 are parallel or L1 and L2 are skew. Actually, when you solve the system, it tells what is the relation between these two lines. Okay, let me give an example. Check the positions. Check the positions of x minus 1 over 2, y plus 1 over negative 3, 2, and z over 3. And the other line, x minus 3 over 4 equals y plus 1 over 5 and z minus 3 over 2. So relative to each other, if they intersect each other, find the intersection point. Okay, so first let's say this is L1, this is L2. So L1 has the direction vector as 2, negative 2, 3. And the point line is passing from, let's say P1, this one, 1, negative 1, 0. For L2, you have this one, D2 will be 4, 5, 2, and the point 3, negative 1, 3. So I will try to find the common solution. If I find there is intersection point and the line intersect each other. Otherwise, I need to check the direction vectors. If they are parallel, then the line will be parallel, two lines. Otherwise, they will be skew. Okay. So from the L1, I have this one. X equals 2 times lambda plus 1. Y equals negative 2 times lambda minus 1. And Z equals 3 times lambda. This is the first one. The other one, x equals 4 times mu plus 3, y equals 5 times mu minus 1, and z equals 2 times mu plus 3. So I put here lambda and here mu. So let's put L1, L2 here. Okay, so we have this system from this together, 2 times lambda minus 4 times mu equals 3 minus 1, 2. And negative 2 times lambda minus 5 times mu. So this will be 0. And 3 times lambda minus 2 times mu equals 3. So I will solve these two together. So this one, 2 times lambda minus 4 times mu equals 2. 2 times lambda minus 5 times mu equals 0. So from here you have okay, mu equals 2 over 9 negative. I consider the two equations, the first two equations, and trying to solve this equation. Okay, so I find the mu. So put this one here, 2 times lambda minus 5 times negative 2 over 9 equals 0. So lambda will be, okay. So now I put this information here. So 3 times 5 over 9 minus 2 times negative 2 over 9 will be 0. So check this one. You have 15 over 9 plus 4 over 9, which is not 0. So there is no solution. So if there is no solution, either L1 and L2 parallel, or L1 and L2 are skew. Now check the D1 and D2. Now if you check this one, so okay, you see 2 over 4 equals negative 2 over 5, which is not, and not 3 over 2. So L1 and L2 are not parallel. So we conclude that these two lines, L1 and L2, are skew. Are not parallel, right? Okay, let me write here, because they are not parallel, D1 and D2. Okay, this is the correct one. Okay, this is our first line. Okay, this is the first line. Okay, these are our lines, but they are not passing from each other. Okay, so let me put in this way. maybe I should. Okay, these two lines, but they are not intersect each other. Okay, it seems like they are, but not. Okay, let me change this one. Okay, this is the case. Let me change. So they are skew, but they are not, because they are not in the same plane. Okay. So this is the one. Okay. You see, they are not in sync because when you change, they are going somewhere else. So it's not same point, okay? Okay. Okay. Another example. Okay, check the positions of the lines x minus 1 over 4 equals y minus 3 over 2 and z minus 4 over 5 and x equals y equals z minus over 8 over 5 relative to each other. If they intersect each other, find the intersection point. Okay, we will follow the same steps. So first put here lambda and here mu, and then we have this one, x equals 4 times lambda plus 1, y equals 2 times lambda plus 3, and z equals 5 times lambda plus 4. This is the first one. The second one, x equals mu, y equals mu, and z equals 8 over 5 times mu plus 1. We have this one. So then from these equations we have this equation mu equals 0 and 2 times lambda minus mu equals negative 3 and 5 times lambda minus 8 over 5 mu equals 1 minus 4 negative 3. So this one will be negative 1, right? This one. Okay. Okay, so consider again first two equations. Mu equals negative 1 and 2 times lambda minus mu equals negative 3. So multiply this one by negative 1. So you have 2 times lambda equals 6 minus 1, 5. No, negative 1, right? So will be 2. So negative 2, yeah, 2. So will be 2. And from here lambda will be 1. So if lambda is 1, then we have 4 minus mu equals negative 1. So from here negative 1, negative 4, 5, negative 5, mu will be 5. So this one and this one. Now we will put this lambda and mu in the third equation. So 5 times 1 minus 8 over 5 times 5 will be negative 3. So you have 5 minus 8 negative 3. So this case. So it satisfies this equation. So they intersect each other. So intersection point will be this one. Intersection point. Okay. So x will be 5, y will be 5, and z will be 8 or 5 times mu will be 8, so plus 1 will be 9. So this P, let's say P sub 0, 5, 5 and 9. It is the intersection point. Okay, you may say, why don't I put this lambda? So it doesn't matter, because if you put the lambda, you will get the same result, because look at here, 4 times lambda plus 1 will be 5, right? 2 times lambda plus 3 will be 5. So because lambda is 1, so the last one, 5 plus 4 will be 9. So it will be same point. So because we were looking for the common solution, so it will be same. Yeah. So this is the intersection point. Find 3 planes parallel to the coordinate axis and x equals 2 times lambda plus 1, y equals negative 3 times lambda plus 2, and z equals lambda minus 4 is lying on these planes. Okay, remember, when you try to find the 3 planes parallel to the coordinate axis, you need a line. But here in the first part, we don't see any line. But in the second line, it says the line, given line, is lying on these planes. So it means actually this line determines these planes. So if you like to write this one, x minus 1 over 2 and y minus 2 over 3, negative 3, and z plus 4 over 1 as a lambda, then you can find these 3 planes. Okay, the first one, negative 3 times x, negative 2 times y, okay, 3 plus 2, 5. No, 7, right? 3, 7. Okay, the other 2, these ones. Okay, so you have x minus 2 times z, negative 1, and negative 8 will be 9. And the third one, y plus 3 times z, negative 2 will be negative 12, so plus 10. So this is the solution. Okay, let me give you another example. This one. Okay, find an equation of the intersection line of two planes. So the first one is 2 times x, 3 times y, plus z, plus 1 equals 0, and negative x plus y plus 2 times z plus 3 equals 0. Remember, we gave 3 methods find this intersection line. So I will use the third one here. So first I need a point. So first let's say the x 0, then you have this equation and y plus 2 times z negative 3. So if I multiply this one by negative 3, then I have, okay, let me write. So from here you have so z will be 8 over 5. Okay, if this is z, then we can find the y. Y will be negative 3 minus 2 times 8 over 5. So y becomes, okay, 16 over 5, 1 over 5. So our point is this. Let's say p sub 0. So 0, 1 over 5, negative 8 over 5. Okay. And then we will find the normal vector. So normal vector will be this one because we have n1, let's say 2, 3, 1, and n2 is negative 1, 1, 2. And D will be N1 cross product N2. So you have 2, 3, 1, negative 1, 1 and 2. So from here you have 5, negative 5 and 5. So then we find the common line. So this one, x over 5, y minus 1 over 5 over negative 5, and z plus 8 over 5 over 5. This is the intersection line. Okay, now another relation between line and point in this case. So distance between a point and a line. Okay, now consider this line L, x minus x sub 0 over p, and y minus y sub 0 over q, and z minus z sub 0 over r. So this is our line, and let P1, let's say x1, y1 and z1 be a point, not located on the line. So we have this one, okay? So this line. So there is a point here, let's say this is a point. So we are trying to find this distance. So distance means the shortest distance we mean. So let me drive this one here, like this one, it will be more convenient. So let's say this line, okay, this line, and then put here. So we are looking at this one, okay? This will be perpendicular. So here we have perpendicular angle. So these are okay. I use D. Let's say U. Okay. So this distance. Okay. Now because our line, we have a point here. Let's say this point is this P sub 0. So P sub 0 is this one. P sub 0, x sub 0, y sub 0, z sub 0. The point on the line. Okay. Now I derived this line segment here. So let's say this angle between this line and this line segment will be theta. So we have the vector this one, D. So here we have P1, right? So first, sine of theta will be u over p sub 0 p1. So this is the hypotenuse. This is the opposite side. So this will be sine of theta. So from here, our distance u will be P1 P0, this length, times sine of theta. Now if theta is the angle between, let's say, this D and this P sub 0 P1, it means you have this one. P sub 0 P1 cross product D, this length. We know this length will be P sub 0 P1 times D times the sine of theta. Okay, now we also find the sine of theta here. Sine of theta will be P sub 0 P1 cross product D over this one, P sub 0 P1 and D. So now we have this one and this one. So put the last one into the first equation because we are looking for the distance u. So we have this one, u equals P sub 0 P1 P sub 0 P1 cross product D over P sub 0 P1 D. So these cancel each other and then we find u. The distance will be this one. U equals P sub 0 P1 cross product D over the length of this D. So this is the formula. Distance between P1, right? P1 and the line. Because if you have L line, you have a point, the line passing from this point, and also have a D. So everything in this formula is determinant. Okay, let me give one example for this case. Find the distance between the point okay 0 1 negative 1 and the line x minus 3 over 5 z plus 2 over 2 and y equals 3. Okay, now our P1 is this one, 0, 1, negative 1, this is P1. So D will be this one, 3, 0, 5, right? 5, 0, 2, and P sub 0 will be 3, 3 and negative 2. Okay, first let me find the P sub 0 P1. So this one will be negative 3, negative 2 and 1. Then P sub 0 P1 cross product D. So you have this one, negative 3, negative 2, 1, 5, 0, 2. So we have this negative 4, negative 4, 11, and 10. So we have this one because we need the length. So the length P sub 0 P1 cross product D will be 16, 121 and 100. So it will be square root 237. No, yeah. 37. Okay, how about D? So D will be okay, this one 25 plus 4, so it will be 29. So the U, the distance will be square root 237 over 29. Or I can write in this way. Okay, now when two lines are given, we find the position of two lines respect to each other, and that there were two cases, right? The one is they may intersect each other, or can be parallel or skew. So if they are skew, we may find the shortest distance between two lines. So now I will give the method how to find this shortest distance between two skew lines. So this is our title, the shortest distance between skew lines. Okay, let's say you have two lines. This is the L1, and then you have another line here. This is skew. So let's say this is L2. So now the shortest. So let's say this is the shortest one. So let's say this is D1. This is D2. Okay, this is D1, D2. So we are looking for these D1, D2. So if you have L1, it means you have this one, right? X minus X1 over P1, right? Y minus Y1 over Q1 z minus z1 over r1. This is L1. L2 x minus x2 over p2, y minus y2 over q2, z minus z2 over r2. These two lines, okay? So let's say you have this one, this your D1 here. So D1 is P1, right? P1, Q1 and R1. So D2 is this one, P2, Q2 and R2. So this D2. So let's say the x1, y1, z1, and x2 is x2, y2, z2. So let me write this a little bit bigger. So let's say this is the point the line is passing from, this one and this one. So we know that because this is the skew, it means you have this one. X sub 0, x1, d1 and d2 are not 0. These mixed product are not 0 because they are skew in the beginning. x1, so this x1. So the direction, the direction vector of d1, d2, this line segment, because d1, d2 will be d1, because d, if you look at this one, this perpendicular d1, perpendicular d2, so it means it will be in the direction of this cross product. So first we see this one. So the length of this of d1 d2, okay, is the projection length of x1, x2 to d1, d2. So we know how to find this projection length. Remember when we mentioned about the inner product, we gave the details about this topic. So then d1, d2 will be d1, d2 will be this length. So the projection of this x1, x2 to this d1, d2. So it means you need to make this one unit vector d1, d2 over this one d1, d2. Okay. Of course, we need to put this one because we are looking for the length. So let me put the absolute value of this one. Okay, this is absolute value. So it cannot be negative. That's why it will be convenient to put this absolute value. Okay, let me give example for these cases. Okay, if they are not skew, if they are they have an intersection point, what is the distance between these two lines? So if they intersect each other, what is this distance between these two lines? Will be 0, right? Because the shortest distance will be the point they intersect each other. So if they intersect each other, there is no meaning to search for the shortest distance because it will be 0. If they are skew, okay, it is meaningful. Otherwise, not. Okay. Skew also contains the parallelity. Okay. So if they are parallel, they are skew. So you can find the shortest distance between them. Okay, this one. So find the shortest distance between the lines. So the first one, L1, let's say, x1 or 2, y plus 1 or negative 1, and z or 3. And L2, x equals y, z equals 0. Okay, first of all, let's check the position of these two lines. Okay, so this one, x1 will be 1, negative 1, 0, right? D1, 2, negative 1, 3. So x2, 0, 0, 0, and D2, 1, 1, 0. Okay, let me check they are skew or not. So I will look at this one. Yeah, 1, 1, 0, 2, negative 1, 3. So it will be convenient to open this one. So 3, 1, 3, 2, 3, 3. So 3 times. Okay, so 1 plus 1, so it will be 6. This is not 0, they are skew. They do not intersect each other actually. Okay. So this one will be x1, x2. So you have this one, negative 1, 1, and 0. So d1, d2 cross product will be 2, negative 1, 3, 1, 1, 0. So you have this one, negative 3, 3, and 2 plus 1, 3. Okay, now we need this one, d1, d2 cross product. So you have this one, 9 plus 9 plus 9. So 27. So 3 square root 3. So then the distance d1, d2 will be this one. Okay, 1 over 3 times square root 3, inner product, negative 1, 1, 0 times negative 3, 3, 3. So you see, you have this one, 3 plus 3, 6. So you have 2 over square root 3. Okay, now another relation between skew lines. So common perpendicular line segments between two skew lines. So again we have this one, so let me draw this again. So you have two lines. Let's say let L1 x minus x1 over P1 y minus y1 over Q1 and Z minus Z1 over R1 and L2 x minus x2 over P2 y minus y2 over Q2 Z minus Z2 over R2 be two skew lines. So because they are skew, so they have a common, so let's say this one and this one. Okay, so this is L1, this is L2. So we have direction vector D1 and direction vector D2. So then let's say this is the common perpendicular line. So you mean this one D1 and D2. So now we are trying to find these D1, D2 line segment. Okay, this one. We will do this. We will search this case. So of course we need to find the D1 and D2. Then use the D1, D2, and then use the formula, the line passing from a point and having a direction vector. So now, how to find this one? Because this is a perpendicular line, so this D1, D2, D1, D2, perpendicular D1. Also, D1, D2, perpendicular D2. Okay. So this system is solved in terms of lambda and mu. So lambda is this one, okay, this lambda, and this mu. So then the common perpendicular line segment can be found. Perpendicular line segment can be found okay, line segment can be found either by using 2 points or 2 pins or 1 point and direction vector. Direction vector is clear. Direction vector is this D1 cross product D2. Okay, now let me give one example how to find this perpendicular common line segment. So this one, find the common perpendicular line segment between the lines. So L1 is this one, x minus 1 or 2, y minus 3 or negative 1, and z plus 1 or 3, and the other line L2, x plus 1 or 3, z minus 2 or 2, and y equals 2. Okay, first of all, we need to check that are these lines skew or not. So if they are not skewed, there is no need to calculate this line segment, okay? Okay, so we need to find this one. So let's say P1, we have this one, 1, 3, negative 1, right? P2, negative 1, 0, negative 1, 2, and 2. 2 and 2. So D1 is this one, 2, negative 1, 3. D2 is 3, 0, 2. So we need to find this one, P1, P2, P1, P2, not cross product, P2, and D1 cross product D2, or we can use the determinant. So these are determinant. P1, P2, negative 2, negative 1, and 3. So D1 is 2, negative 1, 3. And the last one, 3, 0, 2. Okay. So let me write here this calculation. So let me open here, negative 3 times. So I am here now. Negative 3, 0, this one. So this one 0 again. And 2 times. So now I am here. 2 plus 2 will be 4. So will be 8. So they are skewed. Now D1 and D2 are arbitrary points on the lines. So first find these D1 and D2. Okay, to find these D1, D2, I need these, use these lines. Okay. So these are my lines. So now D1 is this one, okay? I write this line as a parametric form. So X will be 2 times lambda plus 1. Y will be negative lambda plus 3. And Z will be 3 times lambda minus 1. So this is D1. D2 is this one. X 3 times mu minus 1, y will be 2, z will be 2 times mu minus plus 2, d1 and d2. Because these are the arbitrary points on these lines, so it will be in this form. So then d1 and d2, d1, d2 will be this one. 3 times mu minus 2 times lambda minus 2. the first component. The second component, so the second component will be lambda minus 1, and third component 2 times mu minus 3 times lambda plus 3. Okay, because these D1 and D2, this one perpendicular D1, so I have this one. Okay, let me bring this one here. Inner product D1 is 2, negative 1, 3, so this will be 0. So if you calculate this one, 6 times mu 4 times lambda minus 4 minus lambda plus 1, 6 times mu 9 times lambda plus 9 will be 0. So you have 12 times mu, okay, 15 times, no, 14 times, 14 times lambda, okay, negative 4, negative 3, so you have 6. So you have this equation actually, 6 times mu 7 times lambda equals negative 3. Okay, now D1, D2 will be perpendicular to D2. Again, bring this one here. Okay, I will multiply this one by 3, 0, 2. So this will be 0 again. So if I multiply this one, then you have 9 times mu 6 times lambda 6 plus 4 times mu 6 times lambda plus 6 will be 0. So now 13 times mu, 13 times mu plus minus 12 times lambda equals 0. So we have two equations. So let me check this one. Lambda will be 13 over 12 mu. So then you put this information here, 6 times mu minus 7 times 12 mu equals negative 3. So you have this one, 72 minus 91 over 12 mu equals 3. So you have this one, mu equals 36 over, so negative 90. So mu will be this one. Now we find the lambda. Lambda will be 13 over 12 times so 39 over 90. Okay, so now I can find the lambda, d1 and d2. So here my d1 and d2. So d1 becomes 2 times lambda plus 1. So two times lambda plus 1 and negative 19 plus 3 and minus 1. So d1 becomes so 97 over 19 so 18 over 19 and the last one 98 over 90. This is d1. d2, I am here now, 3 times mu okay, 108 over 19 minus 1. So this one is 2. So 2 times 72 over 19 plus 2. So d2 will becomes Okay, 89 over 19, 2, and this one, okay, this 72 plus 38, 110 over 19. Okay, these are points. And then the last step is to find the line. The line becomes the line passing from points D1 and D2. Okay, so we have this one, x minus 97 or 19 or 89 or 19 minus this one equals y minus 18 or 19 over 2 minus 19 or 18 or 19, and the last one z minus 98 or 19 or 110 or 19 minus 98 or 19. So these are our line. Okay, let me draw this graph. Okay, this line. Okay, our line common perpendicular line segment. Okay, which one? This one. So this one, this blue one is the common perpendicular line.